Good morning all. Today we will design a gibbon Cotter joint using the Catia software. So this is the design drawing. And it's having 4 parts called square rod, 4 gibbon Cotter pin. This is the assembled view. The part will look like after assembly like this only. And we'll start with by selecting the plane, YZ plane, and we are sketching the part of the taper pin. The taper pin length is of 150, and top side is of 32, and center it will be of 26. Selecting the line. We are making the taper pin by making lines. This of a tapered one. Length is of 150 actually. So by using the erase command, we can able to erase the extended lines, and by using the constraint symbol, we can able to give the dimension of an already drafted object. Top side is of 32 and the is of 150. By using the constraint symbol, we can able to make the distance between any two lines or points. The bottom side is given as 22. In the top side, we are having chamfer. Selecting the corner points, we are going to give the chamfer. That's the chamfer symbol, and giving the degree as 45. The length is of 1 mm chamfer I am giving. So 1 mm chamfer is not enough. So we can alter the length of the chamfer from 1 mm to 5 mm also we can give. It as 2 mm. Let's see 2 mm is enough or not. We can give it as 5 mm. Then only the chamfer is clearly visible. One point that we could miss. So when selecting the points on the bottom side, this is top side. We'll give the chamfer. The length is of 5 and the degree is of 45 degree. Now the chamfer is being made. We recommend with mirror extent of 20 mm. The thickness. So as it is a mirror extent, you can give it as 10 mm on either side. That means of 5 mm on either side, so that it will be of 10 mm, because the size of the hole is also 10 mm. So the second part we'll go for, that is the Cotter pin. The second part is the gib, and there also we have to make that the line at an angle, that is of a tapered gib that we have to make. So I am deleting the line. Using the constraint symbol, we can able to make the line as coincide with the vertical line, and I am deleting the vertical line so that it should be at an angle. So it should be of 150 mm in length. Sorry, 96 mm in length. By using the constraint symbol, we can change over the dimension. Bottom side 32, top side 26. It just reversed with the Cotter pin, the dimension, so that it will be easily merged with the Cotter pin. There should be a tight fit. So this is how the give will look like. Now another part we have to draw is the square rod. Going with mechanical design and part design, the part name is square rod. Dimension is of square 40. Length it is of not specified. We will make a rectangle. The length is of, that is the size of that is of 40. Then the length is of not specified actually, but at least it has to be inside the fork. The dimension is of 42 plus 55 plus 35. 55, 80, 120, 132. At least it should be inside. So the size of the hole is of 10, and I am going to make that hole to coincide symmetry with the center line. 55 mm in length as well as 10 by 55. And from the inner end to that hole, it is of 32 mm. You can see from here to 32 mm. Sorry, 35. It is of 55 mm. So now exit workbench, then going for pad command. That is how the square rod with a hole will look like. Now we have to draw the fork end. Mechanical design and part design. Then that is the fork end that we have to draw. So we are going to draw half of the fork and we are going to mirror it down. Using sketch command. Length is of 132 on the inner side, 162 on outer side. The radius of the chamfer is given as radius 10 and 13 mm thickness. So using the profile, we are going to make a profile. Instead of using the line, if you use profile, you can make continuous lines. Without dimension, I am making a profile. Looks like a fork actually. So using constraint symbol, from the center it is of 20. Actually the total is of 40. Mm. Total is of 132 mm. The thickness of the fork is 13. The length is of 62 mm. Thickness 13. The chamfer radius is given as, not given actually, we're making it as 5. It's of 11.32. We are taking it as 10 mm. On this side it will be a 5 mm. The length is of not specified. I am making it as 100 actually. Using the mirror extend command, selecting the whole part and with respect to the horizontal line, using the uh, now it has been mirrored. Deleting the center line, so actually the radius, the chamfer point should not belong over there. Actually, we have to make the chamfer on this end. The radius is 10. Now using the constraint symbol, we can make that actually the length is of not specified, but still giving us 100 mm. Using the mirror extend command, we can mirror the object and exit workbench. Then using pad symbol, we can able to give the dimension as 20 mm. Now we have to make a hole. We are going to make a hole of rectangle size of 10 mm, length is of 55, and from the inner side, from this inner side, to 35 mm. The length is of 55. Now exit workbench using the hole command or pocket definition up to the last. If you select, then the hole is being created. Now going to assemble the part, going for mechanical design, then assembly design. We can import the parts one by one. We need to arrange the tools. The part name is given as Gibbon Cotter joint. We have imported the first part, that is the 4. Now we have to import the Cotter pin as well as the gib. and that part has to be moved. Actually, the dimension is of, we have to reduce. Actually, it is of mirror action with 10. It should be a 5 mm only with mirror action. The head change the dimension. Now we have to move that gib. So by selecting this manipulation symbol, we can able to drag along any axis, x-axis as well as y-axis also. We can able to drag it down. Now we have to make that part to be exactly being where to constrain those part. This part as well as the fourth and outer part should be joined together. By clicking enter, the part will be fitted over there. And again, we are importing the taper pin. And using the manipulation symbol, we can able to move that Cotter pin and in any direction, selected direction. Using the constraint symbol, we can able to move that Cotter pin along with the gib. If the dimension is mismatched, let me to rearrange it. Instead of 32, we can give it as 20 mm on bottom side. Still, we have to rearrange the dimension. So 22 on bottom side with the cube. Now a perfect fit has been made. So this is how we are making a gibbon Cotter joint using the Catia, and we are assembling it. Thank you.